Welcome to our lesson on the Pythagoras Theorem. By the end of this video, you will be able to identify the parts of a right-angled triangle and use the Pythagoras formula to find any missing side length. First, our title, the Pythagoras Theorem. Our first objective is to identify the hypotenuse, and our second objective is to solve for missing sides using a squared plus b squared equals c squared. We use this theorem specifically for right-angled triangles. Those are triangles that have one corner shaped like a perfect square, which we call a 90-degree angle. The most important part of the triangle to find first is the hypotenuse. The hypotenuse is always the longest side, and it is always directly across from the right angle. We usually label this side as C. The other two shorter sides are labeled A and B. The theorem states that if you square the two shorter sides and add them together, they will equal the square of the longest side. In math terms, that is, a squared plus b squared equals c squared. For our first example, let's learn how to find the hypotenuse when we know the lengths of the two shorter sides. Imagine a right-angled triangle where the two shorter sides measure 6 centimeters and 8 centimeters. First, we identify our sides. Side A is 6, side B is 8, and the hypotenuse is the unknown side C. Because we are looking for the longest side, the hypotenuse, our strategy is to add the squares of the two shorter sides. Let's plug in our numbers step by step. First, we replace A with 6 and B with 8. Now, we calculate the squares. 6 squared, which is 6 times 6, gives us 36, and 8 squared, or 8 times 8, gives us 64. Next, we add these two values together. 36 plus 64 equals 100. Now we have 100 equals c squared. But we want to find c, not c squared. To undo a square, we take the square root of both sides. The square root of 100 is 10, because 10 times 10 equals 100. So, the length of the hypotenuse is 10 centimeters. In our second example, we will learn what to do when we already know the hypotenuse, but are missing one of the shorter sides. Consider a right-angled triangle where the hypotenuse is 13 centimeters and one of the shorter sides is 5 centimeters. We need to find the missing side, which we will call x. Notice that the longest side, across from the right angle, is already known. When finding a missing shorter side, our strategy changes slightly. We must subtract the square of the known side from the square of the hypotenuse. We start with the theorem. X squared plus 5 squared equals 13 squared. Let's calculate the squares. 5 squared is 25, and 13 squared, which is 13 times 13, equals 169. To get x squared by itself, we need to move the 25. We do this by subtracting 25 from 169. When we perform the subtraction, 169 minus 25 gives us 144. Just like before, we need to find x, so we take the square root of 144. The square root of 144 is 12, because 12 times 12 equals 144. The missing side length is 12 centimeters. For our third example, let's practice finding the other missing shorter side to make sure the steps are clear. In this problem, we have a right-angled triangle with a hypotenuse of 25 meters and one side measuring 24 meters. We need to find the remaining side, which we will label as x. Since we are looking for a shorter side, we know we will eventually be subtracting. We start by setting up our equation using the Pythagoras Theorem. Let's find the squares of our numbers. 24 squared, which is 24 times 24, equals 576. Next, 25 squared, or 25 times 25, equals 625. To isolate x squared, we need to remove the 576. We do this by subtracting 576 from both sides of the equation. When we subtract 576 from 625, we are left with 49. The final step to find the value of x is to take the square root of 49. Since 7 times 7 is 49, the square root of 49 is 7. So, the length of the remaining side is 7 meters. To wrap up, let's review the key rules for using the Pythagoras theorem effectively. First, always remember that this theorem only works for right-angled triangles. If there isn't a 90-degree angle, this formula won't apply. Second, identifying the hypotenuse is the most important first step. Always look for the side opposite the right angle and label it as C. Identifying C correctly ensures you set up your calculation properly. Our calculation strategy depends on what we are looking for. If you are finding the hypotenuse, you add the squared values of the two shorter sides. If you are finding a missing shorter side, you subtract the square of the known side from the square of the hypotenuse. Now you have the tools to solve for any side of a right-angled triangle. Great job following along with these examples.